Hello guys, welcome back to ptet.chemistry channel. So in this tutorial video, I'll go through this progress test, which is essentially a year 9 5070 syllabus for those sitting for the 2023 examination series for the Cambridge International Exam. This is a school level exam. It's a year 9 exam. Well, for the first 3-4 months of the year 9 curriculum, they will have covered the expected states of matter, atomic structure, as well as chemical structure and bonding. So this paper consists of 2 sections, which is the MCQ and the structured paper. The MCQs are not the whole 40 question MCQ in a full O-level paper setting. Similarly, the structured paper is not a full structured component paper for the whole 1 hour plus paper. Instead, for this school level exam, things have been jumbled together for a mixture of both kind of paper together in just one paper. Anyway, jumping straight onto the first question. So we have bromine, which is a liquid at 20 degrees Celsius, and you should know that bromine exists as Br2, just like all the other group 7 element. So F2, Cl2, Br2, I2. So they all exist as this thing, what we call as diatomic molecule, as a result of each atom wanting to get to a fully filled outer shell that forms single covalent bond between themselves, just like that. These two are gases at 25 degrees Celsius, which is room temperature and pressure. This thing is a reddish brown liquid, and this thing is a black solid. Looking at this way, we can see the melting point increases as a result of stronger intermolecular forces of attraction between the molecules, and to do with changes of states for simple molecular structure. We are breaking these weak intermolecular forces without doing anything to the covalent bond at all. So if it is a liquid at 20 degrees Celsius, which it is also a liquid at 25 degrees Celsius, room temperature is not 20 degrees Celsius, instead it's 25 degrees Celsius, just so you're aware. So you're looking for 20 degrees Celsius in between the melting and boiling point. When you have a heating curve, you should really have a feel for this thing, where in a heating curve you have time on the x-axis, minute or second, temperature in degrees Celsius or Kelvin. If this is melting point, if this is boiling point, so that is when the transition happen. So we are looking for something where it's a liquid there. So we're looking for 20 degrees Celsius in between the boiling point and the melting point. 20 degrees Celsius in between. Clearly this is negative and negative, so A is out. Again, this is negative and negative. 20 degrees Celsius do not exist in between. 20 degrees Celsius is lower than 25, so 25 degrees Celsius is bigger than 20 degrees Celsius, so D is out. And you can see in between -7 and 59 you have 20 degrees Celsius, where bromine would be a liquid. Question 2, particles in substance that are widely spaced. Widely spaced means very far apart, wide, huge separation. So widely spaced, very far apart, able to move freely. We are thinking about a gas really, and they go to a state that changes to a state. So you're going from a gas to something, okay? Because it's from the gas to something, to the state in which the particles are in contact. So they are close to each other, but still able to move freely. Not solid, because solid particles can only vibrate about fixed position. Solid particles never move freely. Therefore, we are looking at liquid. So gas going to liquid, that is going to be condensation. It all comes down to reading question. When you read question, interpret information, circle and underline, because if you're just reading question and if you have been making mistakes, then it hasn't worked out very well for you, and unless you change now, you will struggle in the future similarly. Question 3, we have rates of diffusion. So we have gases. Ammonia is NH3, is one of the many simple molecular structures, molecules of which you need to know how to draw the dot and cross because they are within the syllabus where candidates are expected. Candidates should be able to draw the dot and cross for each and every one of these based on your syllabus. Okay, carbon dioxide. Hydrogen bromide is not necessarily in your syllabus, but you got something which is very similar. It's called hydrogen chloride, and bromine is below chlorine in the periodic table. So hydrogen chloride forms single covalent bond like this. Therefore, HBr also looks similarly. Okay, CO2 looks like this, where the carbon forms 4 bonds and each oxygen forming 2 covalent bonds. By drawing the display formula, you can translate them into the correct dot and cross by not only considering the central element or central atom, but also how many electrons around each and every atom. Okay, for the full complete dot and cross. These are all simple molecules. When you talk about simple covalent molecules, of course they have simple molecular structure, then they have covalent bonds, but they also have intermolecular forces between the molecules. Just like in the previous question I've drawn here, between the molecules is intermolecular forces, between the atom is called covalent bond. Now this question is asking a rate of diffusion. It's not asking you on melting or boiling point. So we know diffusion is to do with relative molecular masses. So this is come down to using the periodic table. The molecular mass of NH3 is total up the individual masses. There are 1 nitrogen atom, that's why they don't show you that. Each nitrogen atom has a relative atomic mass of 14 given in the periodic table, which you should know what is relative atomic mass from your definition in topic 2 syllabus. And you have 3 hydrogen, each of which is 1, but you got 3 hydrogen. I'm adding them up, I'm not multiplying because I've got 1 nitrogen and then plus 1 plus 1 plus 1, which is 3 times 1. Okay, you should know how to do this from your topic 1 checkpoint, and then your topic 1 exercises, and then your topic 1 topical test, which all of these have been reinforced again and again and again. Okay, so 16 is the relative atomic mass for oxygen. 8 is the proton number of oxygen. This is molecular masses. These are not proton number. Be very careful. So 12 plus 32 is 44. And then the last one that you want is HBr. So there's 1 times 1 plus 1 times 80 in your periodic table. So it is 81. So the heavier you are, so heavier molecule, bigger MR, diffuse slower. Okay, so this is an MCQ in structure. That's how you explain as well. So the slowest will be the heaviest molecule, where you show the calculations as part of your working in ink, because these are your explanations. So HBr is the slowest, and the fastest will be the lightest. The lightest meaning the smallest molecular mass. There's 17 for ammonia. CO2 is in between there. Question 4. So we got electronic structures, or sometimes they call it electronic configurations. Sometimes they call it electronic arrangement. So basically it's how the electrons are being arranged in the shell. What I can tell you is, I can tell you the period number. Period number, as stated in the syllabus, candidates should be able to state. It's just stating that period number refers to the number of shells being occupied, number of shells being filled. There's only 1 shell being filled. We use Arabic numeral. There's 2 shells being filled. This is the first shell, which is closest to the nucleus in the middle. Innermost is the first shell, then the second shell. First shell, then second shell. First shell, second shell, third shell. So there are 3 shells here. And now in terms of group number, The next bit of the syllabus, straight after the period and the group, in atomic structure of the 5070 for the 2023 syllabus, it says group number. Candidate should be able to state that group number refers to, or group number is the number of valence electrons, the number of valence electrons, meaning the number of electrons in the outermost shell. This is the only shell, this is the outermost shell, there's only one electron. This is the first shell, this is the second shell is the outermost shell, second shell is the valence shell, there's only one electron in there. Okay, sorry, I should really use Roman numeral. I use Roman numeral for my group number as given in a predict table for free, by the way. This one is 1, 2, 3, 4, 5, so this is group 5. Here this is 1 and 2. There's no other electrons in the valence shell, there's group 2. Now they're asking us which of the elements are metals. Group 1 usually we will associate it with metal. Usually metal, however, you need to be careful. Period 1, group 1, only one electron. So we are looking at hydrogen. And when you look at hydrogen, you know that hydrogen does not form metallic bond. It's your case study. Hydrogen, they form this single covalent bond so that each of the hydrogen get to a fully filled outer shell, because these are part of your simple molecular structures case study among the many simple covalent molecules which you did the exercise of based on the syllabus. So this is not metal, non-metal. This is why hydrogen with carbon, hydrogen with any other non-metals, they form covalent bond. This is element number 2. This is period 2 group 1. This is actually lithium. And period 2 group 5, this is nitrogen. This is period 3 group 2. This is magnesium. This is metal. This is non-metal. As you know, we have a lot of nitrogen existing as a N2 molecule, as an element. This is atom. This is element, which can be atom or molecule, but it exists as a molecule because they want to get to a fully filled outer shell. Lithium is a metal. So we're looking at element 2 and element, hang on, what am I looking at? Element 2 and 4. Am I correct? Let me see. Oh yeah, element 2 and element 4. Okay, so there is lithium and there is magnesium there. Whereas if you say 1 there, 1 is hydrogen. Yes, even though it's group 1 because it's got one valence electron, but hydrogen is never associated with being a metal because they form covalent bond with itself. They don't form metallic bond with itself, unlike the metals, which has giant metallic structure that you know how to draw and label. Hydrogen doesn't do that. Question 5. So some properties are elements in the same group. So you know same group means same number of valence electron. This is stated in the syllabus very, very clearly, and they have all been tested many, many times in your checkpoint questions, in your exercises, which you did corrections of before you did the topical test, which again you did corrections of before you sit for this test. Okay, and you have charges on the ions. That is correct. Think about Li plus, Na plus, K plus, group 1 example. Okay, number of outer shell electrons, that refers to valence. Outer shell refers to valence, so number of valence electrons means number of outer shell electrons. Number of protons are definitely not the same. Example, not the same. Okay, different elements, different number of protons. Total number of inner shell electrons, again, not the same because this depends on period number. Okay, so which one show an increase? Hang on. What do they want us here? Okay, what do they want here? Be careful. These are the same. These are the same, but which one show an increase? I.e., not the same. So they don't want what is the same. They want what is different. Show an increase, different. So they don't want what is the same, so therefore not option 1 or option 2, but option 3 and option 4. Okay, so again, it all comes down to reading question very carefully. So it must be option 3 and 4 there. Number 6, we have structure of an ion. So again, reading question very carefully. Ion. So this is an ion. This is an ion. Is it positively charged or is it negatively charged? Well, we got to count. There are 13 protons, information number 1. So 13 times plus 1. And how many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there are 10 electrons. 10 electrons, therefore 10 times minus 1. Okay, so when you have 13 protons but you have 10 electrons, 13 proton but 10 electron, this is an ion. You have more protons than electrons. This is going to be a positive ion. This is going to be a cation. Cations come from metals. Metals lose electrons to form cations. That is actually part of the syllabus that come under the first bit of structure and bonding, where they say candidates should be able to state that metals lose electrons to form cations as a result of counting protons and electrons based on this diagram given, and they even told you it's an ion. So now, what is the correct position from which this ion was formed? Okay, so you lose how many electrons? You lose 3 electrons. You lose 3 electrons. Therefore, group 3, because it's got lose 3 valence electrons. So we're definitely looking at group 3, not group 0, because this is the resulting ion that is fully filled outer shell. By reading the question, by underlining, by not getting tricked, because you keep your eye open for all this kind of danger, because you have done enough practice, because you know the exam skills, all right, to be tricked easily like this. Now, in terms of period, which period are you from? To go from here to here, you lose 3 electrons. Now you have 2 outer shells. This is 2.8. Previously, you have 2.8.3. This is the first shell. This is the second shell. This is the third shell. Previously, you had 3 shells that are being filled. So previously, you were period 3. After you lose the 3 valence electrons, then your valence electrons are now the second shell electrons, because now you only have 2 shells. But originally, you have 3 shells that were being filled. Question 7, which statement is true? So we compare argon and chloride. Well, I guess you can look at proton. This is 18 and 17. This is an atom, so number of protons equal to number of electrons. This is an anion, so you have gained 1 electron because you have a -1 charge. So that means you have 1 extra electron than the proton. From the atom, you gain 1 electron because it's -1 charge. So you have 1 extra electron. So it's 18. This one is incorrect. And then we need to compare with K+. If I just put on K+ here, K+ is potassium ion. So it has a +1 because you have lost electrons. Again, it's from the syllabus, which you need to know how you get cations by losing electrons. And these are all provided in corrections, as well as all the feedback file, all the feedback that I specifically specified to you that you need to learn from your mistakes and never to repeat them again. So more electrons, that is incorrect. Instead of going through something like this, which is tricky, I will go through this K and K+. If I have K, this is an atom. So if I have 19 protons, I have 19 electrons. So K to K+, K to K+, potassium atom has more electrons than potassium ion. Potassium atom has more electrons than potassium ion. So that is definitely correct. Even though this is option D, but between C and D, I always go for the one that I can check because I'm left with two options. Check something that you can check definitely, okay? Iron 2 plus to iron 3 plus, to increase in the charges means you lose 1 electrons from iron 2 plus to iron 3 plus. You become a higher charge cation because you lose electron. So when you lose electron, how can you have more electrons than what you started with? Alright, that's why C is also wrong. What I was just doing was I went straight for D because it's a lot easier to check for D, something you're familiar with. Number 8, an element has p protons and n neutrons. Protons and neutrons are what you call nucleons. This is an element. Possible correct number: protons, electrons, neutrons in a negative ion. Negative ion, why am I doing that? Negative ion, so therefore has more electrons than protons. So if your proton has p and you are isotope, so you need a lot of things, yeah. You have a negative ion, so there's condition number 1. This is isotope, this is condition number 2. Different number of neutrons than R itself, okay? Then the previous well, basically the isotope have the same proton number but different neutron number. If you have n neutron, so your neutron can be +1 or -1, doesn't matter, but as long as it's different number of neutrons than this, so this is still correct. But how about electrons? Typically, when you are different number of neutrons because they are isotope, the electrons will be the same as proton. However, if you read the question carefully, this is negative ion, and negative ion has more electrons than proton. More electrons than protons. So it's got to be this one. So the only answer there must be A. It all comes down to reading question and not getting tricked easily. Question 9. Which pair of elements form a compound by sharing electrons, i.e. they form covalent bond? And when they form covalent bond through the sharing of electrons, we are looking at non-metal and non-metal as part of something you did in introductory bit on structure and bonding. Okay, so carbon is a non-metal, chlorine is a non-metal. We already got our answer there. Lithium is a group 1 metal, and iodine is a group 7 non-metal. As you could imagine, you could have Li plus, I minus, which is what you call lithium iodide. Alright, it's going to be ionic compound with the strong electrostatic force attraction between the two oppositely charged ions. Neon is a noble gas. Noble gas exists as single atom because they do not like to form any kind of bond at all. Not ionic, not covalent, because they already have fully filled outer shell. So C is wrong as well. Potassium is again another group 1 metal, so I'll just use pink color there. This is another group 7 non-metal, so you have K plus, Br minus, which is KBr. This is called potassium bromide because it's a Br minus ion. It's also ionic compound. Ionic compound involve ionic bond between the cations and anions that are formed as a result of transfer of electrons, meaning something has lost and something has gained the electrons. So for question 10, we have this molecule is ethyl propanoate. You will learn more about it in organic chemistry towards the end towards the end of your O-level in year 11. Anyway, it's really asking you how many bonding pairs of electrons. The key thing here really is a pairs of electron. Alright, so each of these line is a pair of bonding electrons. So if you could imagine, if I have CH3, so each hydrogen forming 1, 1, 1 like this, and then this is CH2, so there's 2 hydrogen, each of which are single covalent bond. So this is H, carbon form 4 covalent bond. So this is CH3, so there's H, and H like that. So the whole idea of the question giving you like that is so that you only count what you see, but they are trying to trick you that you are miscounting the one that you don't see, even though these are covalent bond, and each of these covalent bond is a bonding pair of electron. So altogether now you have single bond, but you also have double bond. Double bond means 2 covalent bond. 1 covalent bond is 1 bonding pair because it's 2 electrons. 2 covalent bond means 2 bonding pair of electrons. That means 4 electrons being shared all together. So be careful there. So let's start counting. And if there's an easier way of me to show this, let me use green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there are 17 bonding. These are pairs of electrons bonding because they are the one used for forming covalent bond. And a lot of students who just see the black lines given 1, 2, 3, 4, 5, 6, 7, they'll put down 7 as the answer incorrectly. Okay. Question 11, so you have ethane, which is an organic compound here, C2H6. If you draw out the display formula, you can see carbon form 4 bonds, each hydrogen forming single covalent bond, and then NH3 is like that, with lone pair because nitrogen is from group 5, carbon is from group 4, you got 4 crosses. This one of which come from each of the carbon. Alright, so which statements are correct? A molecule of ethane, this is one molecule, contains twice as many hydrogen atoms. So here you have 1, 2, 3, 4, 5, 6. So you have 6 hydrogen atoms. Here you have 1, 2, 3. So you have 3 hydrogen atoms. Twice meaning 2 times. So yes, 6 is 2 times 3. So 1 is correct. Okay. And uncombined, so meaning not bonded, and this is atom. So the key thing is atom. You have 5 outer electrons. Well, 5 outer electrons mean 5 valence electrons. Nitrogen is group 5, so it's got 5 valence electron. That is correct when it is not bonded to anything as an atom. In a molecule of ethane, this is one molecule of ethane, the bond between the carbon atom is formed by sharing 2 electrons. The bond between the carbon atoms, which is this thing, it's got 1 from each carbon, and that is correct. As you could see the cross there, 1, 2, 3, 4. Doesn't matter which one is which one, but one of which come from here, and the other one will have come from the other one. 1, 2, 3, 4. Okay, so 1 from each carbon atom is correct, and is formed by sharing 2 electrons. As you can see, 2 electrons being shared, 1 from each carbon. So it all comes down to reading questions, so all of them are correct statement there. Question 12, you have a metal and a non-metal. The metal loses electrons in order to form cations, in order to get to a fully filled outer shell. The non-metal will gain the electrons and it will form anions in order to get to a fully filled outer shell. Now you get this ionic compound, you have 2 of X, 1 of Y. Okay, so meaning to say you need more X than Y. So well, if you think about this, if each of X give away 1 electron, so you're looking at correct, right? Each of X give away 1 electron, whereas X receive electron. You see here they say metal is X, metal lose electron. So X receiving electron is incorrect, B is out. Y is the non-metal, it gain electron, so Y give away electron. Y give away electron is incorrect. So at least now you're down to A and D, so you need to choose which one is correct based on how they have combined. Okay, if X give away one electrons, loses one electron only, so therefore X has one valence electron. If X has one valence electron, okay, if X has one valence electrons, then it's going to be X plus because it's group 1. Okay, let's see how about this one. If Y gains one electron only, therefore Y is group 7, therefore Y minus. So we need to decide which one is actually correct. Okay, the fact that you need 2 of X and 1 of Y, so Y cannot be receiving one electron only, because if Y receive one electron only, then you would form single covalent bond. If Y only gain one electron only, then why in the world does it form bonds to 2X? Instead, if you only need one electron, it would just form a single bond to X. Sorry, not covalent bond. It would just need one of X to give away one electron. So you know this thing is definitely, for this thing to be true, Y cannot just gain one electron. Alright, so don't get confused between covalent and ionic. This is gaining one electrons, cannot be. C formula. If you see the formula, you can see that there are 2X required for 1Y. 2X required for 1Y, so Y cannot just gain one electrons because there are 2 of X required for 1 of Y. So D must be wrong, A must be the correct answer by elimination. Question 13 is to do with giant metallic structure. So when you have giant metallic structure, you know you have cations, and you know you have C of delocalized valence electron. So delocalized valence electrons, and you have the cations. Now you pass the electric current. Current is to do with flow of electrons, as you will learn in the physics bit of the O-level syllabus. In physics, current is defined as a flow of electrons. You pass it for several minutes and then you switch off. In your checkpoint questions, we know that for the flow of electric current, or for the flow of electricity, it's the electrons that move around. It's the free electrons in metals that allow the conduction of electricity. The cation does not move. The cations do not get replaced, but the electrons move around the circuit, so the valence electrons get replaced, while the C of delocalized valence electron get replaced every now and again for as long as the current flows through. But then, if you read this question, you switch it off. As soon as you switch off, then the valence electron would have been replaced by new valence electrons as it flows around the circuit, but the cations remained, and because you are switching off the current already, so you will get back the giant metallic structure. It cannot be the electrons are going to one side because current is no longer moving. So what do I have? What looks like a correct option here? Would be, if you, I don't know what is the best way to visualize this. You do not replace the cation. If you see here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this looks exactly like this. So this must be 14 cations. Here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you only have 10 cations. So you have replaced the cations. But cations do not move. Cations do not move or get replaced when current flows, because current is a flow of electrons, as you would define in physics, right? So B is out. So if I look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it is 14 there as well. Whereas this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that one is 14 as well. So there's really nothing much I could do there. What is different? What is different here is the electrons will have been replaced by new electrons as the current flows. So they do get replaced. If I count the electrons, I guess that's probably where I'm going. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you only got 10 electrons. Okay, so here you got 14 electrons just now. 4, 4, 6, yeah. Okay, so the electrons, the valence electrons, gets replaced as current flow, but you do not get a decrease in the electron because you turn off the current already. You turn off the current already. How can the electrons be decreasing? You are not forming cations because these are metal. You are not forming cations because you are a metal. You haven't got any non-metal here to form ionic bonds. All you are doing really is you have just turned on the current and you turn off the current. So the number of protons and electrons must still balance. The number of electrons that you had originally must still be the same. So C cannot be the answer. So A can only be the correct answer there. Question 14. You need to read this question carefully. They are in your syllabus, these three especially. If I just sketch them out, okay, and you should be able to sketch them out easily. Oxygen is in group 6, it forms 2 covalent bonds. Hydrogen forms single covalent bond. Carbon is in group 4, it forms 1, 2, 3, 4 covalent bond. Oxygen forms 2 covalent bond because oxygen is in group 6. Each of these, oxygen, hydrogen, are non-metals. Carbon is also non-metal. CH3OH is what you call methanol. It is among the 12 or 11 covalent molecules that you are expected to know the minimum. Okay, the minimum thing in the syllabus is the minimum thing you must be able to draw. Carbon forms 4 covalent bonds. Oxygen is group 6, it forms 2 covalent bonds. Each of the hydrogen forms 1 covalent bond. The other one, when you see CH3, well, carbon and hydrogen form single covalent bond. The carbon there is not happy because 1, 2, 3 covalent bond, but it's got a C there, and then it's got a OOH. It forms double bond to this oxygen. This oxygen is happy, but this carbon is still bonded to one other oxygen, and it cannot be double bond there because carbon already formed 1, 2, 3, 4 covalent bond. Instead, you have OH, which which this formula actually says hydrogen forms single covalent bond, oxygen forms 2 covalent bond, can be 2 single or can be 1 double. Now, in which pair of molecules does oxygen form at least 1 double bond? 1 double bond in both molecules. The question is at least 1. They don't need 2, they just need 1. Well, obviously we are looking at this thing here. These are double bonds. So we're looking at 4, we're looking at 2. So 2 and 4 must be the correct answer there. So being able to sketch this out without drawing the dot and cross are very, very important when you want to do this kind of MCQ question all in 1 minute, because you only have 1 minute for each MCQ question. Next thing, this is to do with working out which group of the periodic table does Q belong. If you look at this carefully, it looks like Q has 4 covalent bonds, but this is a normal covalent bond, normal and normal. So this is normal covalent bond. I say normal covalent bond because each atom shares 1 electron from each atom. 1 dot, 1 cross, 1 dot, 1 cross, 1 dot, 1 cross. Here is 2 cross. So what can we say? Cross is from Q. So total cross equal to 5. 1, 2, 3, 4, 5. So it must be group 5. This is actually reminiscent, or should remind you of this thing called ammonium. and it's not the first time you have heard of ammonium ion, and you know NH3, which you see again is like this. NH4 plus is because NH3 has two electrons there that can be donated. It gets donated to a H plus. That's why total you have a NH4 plus, because it pick up a H plus. H plus has no electrons. That is something you have counted. H plus has 0 electron, something you have counted from atomic structure. So they require both the electrons coming from this nitrogen, which is or any group 5 element. In fact, even phosphorus will do the same thing as well, because phosphorus is below nitrogen in the periodic table. Question 16, element Q has an electronic structure of 2 and 4. So this is first shell. This is second shell. So this is period 2. This is group 4. In fact, it is carbon. Okay, because it's an element. And then this one is third shell. So this is period 3. Group 6, because it's got 6 valence electron in the outermost shell. This one has got 4 valence electron in the outermost shell. So this one is going to be sulfur. So now what is the formula of the compound formed between Q and R? So when you have carbon, which is a non-metal, and then you have sulfur, which is also a non-metal. So we are looking at non-metal and non-metal compound. So they're going to form covalent bond. Covalent bond means not ionic, and therefore if you have carbon, if you have sulfur, well, they're gonna do like this, because you know CO2 is in your syllabus. CO2 is one of the 11 or 12 simple covalent molecules, which you need to know. And oxygen is also group 6, but they are in period 2. This is group 6, period 3. CO2 looks like this, CS2 looks like this, and therefore you can imagine that it will be 1 of Q and 2 of R, so it's QR2 there. Alright. Question 17, so you need to identify the correct identities. Methane is CH4. There are, well, it is one of the many case study which you need to know how to draw. Silicon dioxide, SiO2. So SiO2 is this giant molecular structure. Each silicon is bonded to 4 oxygen. You must be able to freehand draw them, because they are your case study in giant molecular structure. Okay, so each oxygen is bonded to 2 silicon, 2 covalent bond, 2 covalent bond, 2 covalent bond there, because oxygen is in group 6. Okay, and then I just show it like this. This is giant molecular, or you can call it giant covalent structure. Okay, iodine is a group 17 element, but because they are group 7 element, so it's got 7 valence electron, so it's gonna want to form things like that. If you can imagine relationship to Cl2, Br2, then you know it will be II, simple molecular structure. Because they are simple molecular structure, they have got covalent bond between the atom, but you also got weak intermolecular forces, and that is what you break in order to melt or boil simple molecular compounds. Graphite is basically carbon, but not bonded to 4 other carbon. It's like a layer structure. Again, you should be able to freehand sketch graphite. Okay, and then I'm trying to draw the other layer. So my diagram is not super perfect, but it's got van der Waals there. It's got van der Waals between the layer, and it has got covalent bond throughout the structure. Giant molecular structure, you need to break many strong covalent bonds in order to melt and boil graphite. Van der Waals forces between the layer is what you break when you try to slide the layer. That's why they are used as a lubricant. But structure and bonding, it is still giant molecular or giant covalent structure. So you still need to break many strong covalent bonds within the structure. Very high melting and boiling point. These are negative melting and boiling point, very low melting point and boiling point. We are looking at simple structure. The rest cannot be simple apart from this one. This is probably simple, but this is going to be a gas at 25 degrees Celsius, which is room temperature. This is going to be a solid at 25 degrees Celsius. So there's got to be iodine, which is a black solid. This is a greenish gas. This is a dark reddish brown liquid at 25 degrees Celsius. This is a gas. This is a liquid. This is a solid. So Y must be iodine and W must be methane. And without going through the rest, we already got our answer here by just knowing methane and iodine and looking at their states of matter based on melting point and boiling point. The next question, the melting point of aluminium oxide. So aluminium is a metal, Al3 plus cations, O2 minus anion. I hope you know by now how to combine to balance out the charges. Aluminium oxide is an ionic compound. It has no charge. You want to balance out the charge. You do something called LCM, lowest common multiple, from primary school mathematics. The LCM is 6. Altogether, you want 6 electrons being transferred. So this is plus 3. You lose 3 electrons. You want both of them to involve a total of 6 electrons. So you will have Al3 plus times 2, then plus 3 times 2 is plus 6. You get to 6 electrons being transferred total from 2Al3 plus. Then you have O2 minus. You gain 2 electrons. You want altogether to gain 6 electrons. So what you do then is you have minus 2 times 3 equal to minus 6. So you need 3 of the O2 minus. Then the total plus 6 cancel out the minus 6. Then you will get the formula of Al2O3. This is the formula for aluminium oxide. Or alternatively, you can use the crisscross method, which I have shown you in the class, and you know how to do it because you actually went home and did it and do the practice on your own until you're very good at it before your exam. That's why you know how to do it, because you did it, you did the correction, you applied it to your own understanding there. This is calcium oxide, calcium 2 plus O2 minus, plus 2 minus 1, 1 and 2. Am I correct? No, minus 2. So, you get 2 and 2. So 2 and 2 is not the simplest ratio. So you need the simplest ratio, which is 1:1. Or you can just think of it as being calcium 2 plus O2 minus. The plus 2 cancel out the minus 2 in exactly 1:1. So it's just calcium oxide formula. So here you have Al3 plus, O2 minus, O2 minus, O2 minus, Al2O3, that is your understanding, versus calcium 2 plus, O2 minus. The O2 minus is the same as the O2 minus, but the 3 plus is not the same as the 2 plus. So 3 plus is smaller, well, it's a bigger charge than 2 plus. And therefore, this bigger charge than the 2 plus 2 is going to have stronger attraction with the O2 minus there. And also this thing has less shell than this one. This one has more shell. If you look at electronic configuration, this one has 18 electrons, so 288. This one has neon configuration, so only 10 electrons, which is 28. Only 2 shells, film, but bigger charge, but plus 3 charge. Alright, whereas this one, 3 shells fill, lower charge or smaller charge. than Al3 plus. So of course we are looking at this thing, what could explain why the ionic bond is stronger. Okay, the ionic bond is stronger because, well, one factor is to do with the number of shells being filled, and the other one is definitely to do with the +3 charges versus the +2 charge. A calcium ion has a smaller charge, which is calcium 2 plus, and this one is Al3 plus. So that's the best reason there. Question 19. So you have copper metal, you have copper 2 sulfate. Sulfate is this SO4 2 minus, Cu2 plus. So it's a giant ionic structure, as you could see, metal cations and these polyatomic nonmetal anions. This is a giant molecular structure. This is a giant metallic structure. So these are your vocabulary. Molten sodium chloride. So there is your giant ionic structure as well. So there is a giant ionic structure. This is aqueous. Remember, the ionic compound can conduct when molten and aqueous. Molten and aqueous because the ions are free to move around to conduct electricity. So which pair will conduct electricity? Because they contain mobile ions. So we're looking at the reason for why they can conduct electricity. They contain mobile ions. Graphite is to do with electrons, so graphite is definitely wrong. Graphite is to do with free electrons because each carbon in graphite only forms 1, 2, 3 covalent bonds. So each carbon in graphite has 1 free electron because carbon has 4 valence electrons. Each carbon in graphite only forms 3 covalent bonds. Therefore, each carbon in graphite has 1 free electrons, and it's got nothing to do with ions, it's to do with free electrons. So C and D are out. Metals conduct electricity as a result of the free delocalized valence electron. This relates to the question earlier. The metals conduct electricity because the electrons move around as the current flows and they get replaced by new electrons, but you don't decrease in the number of electrons. The cations don't move at all. So even though you have cations in the giant metallic structure, you have cations, but it does not conduct electricity because the cation, it conducts electricity because of the electrons, the free delocalized valence electrons that move. So it cannot be the copper metal. I should probably use a different color so that it's emphasized. Okay, not the cations that move. And this is the exact same question from the checkpoint questions on giant metallic structure when we did through the lesson, and also in the test as well, in the topical test on chemical bonding, specifically on metals, which we did corrections on as well. So there should be no mistake when you see this kind of question again and again, unless you never learn from your previous mistake. And the same thing will happen the next time you face this kind of question if you don't learn your mistake right now. Okay, not the cations that move, it is the free delocalized valence electrons that move, okay, for metals. So now I know B is wrong, which means A must be the only correct answer there. Question 20, this is the last question of this MCQ in this paper. So we have properties of 4 substances. We are looking for a structure which is electrostatic force attraction between oppositely charged ions. So we're looking for ionic compound. We are looking for cations and anions. All right, so conduct electricity when solid. That is to do with metals. Metals has metallic bonding between cations and the sea of delocalized valence electrons. Okay, valence electrons are not ions, they are different, so it's not metal that we're looking for. Only metals conduct electricity when solid, apart from graphite, which even though it being giant molecular structure, but as mentioned, each carbon in graphite only forms 3 out of 4 covalent bonds, so each carbon still has 1 free electron on graphite to conduct electricity. Now you're looking for ionic compound. Ionic compound has this strong electrostatic force attraction called ionic bond, so we're looking at high melting point and boiling point. This thing is very low melting point and boiling point. This thing refer to simple structure, simple molecular structure. So straight away you can cross out A because there's simple molecular structure. Now ionic compound, also stated in the syllabus, conducts electricity when molten or aqueous, because you have got free ions. Okay, when you become molten or when you are dissolved in water. So here, conduct electricity when molten, yes. Conduct electricity when molten, no. So D is wrong, only C is the correct answer there. So now moving on to the section B, which is the structured questions. We are given these 5 boxes that describe 2 solids, 2 liquids, and a gas. Classify each of these as an element or a compound or a mixture by placing a tick. A tick meaning like this. They are not asking for a cross. They say a tick. Means one, just one tick in the correct column. So they can either be element or compound or mixture. They are not saying and, they're saying or. So you just need to have one tick for each of F, whether it's here, here, or here, and for G, H, I, and J. So you got to read the instruction here in terms of properties. If you look at F, when you have a magnet onto solid F, some of the powder is attracted to the magnet. So we're looking at something which is magnetic. Perhaps we're looking at metals. Okay, compounds won't be magnetic, but metals itself are magnetic, and metals are elements, and metals are not compounds. And they say, what are we saying? However, what do we have here? They say some of the powder, not all of the powder. So the fact that even though metals are elements and any metals will be attracted to the magnet, but not all the powder is attracted to the magnet, that means we have got metal plus something else. So there is not going to be a pure element because of not all of them are being attracted to the magnet. So we're looking at this being a mixture. Therefore, it's a mixture. So F must be a mixture there. If you look at G, liquid G is the only chemical form when hydrogen burns in oxygen. Hydrogen does not exist as hydrogen atom. These are from the syllabus under structure and bonding as part of the 11 or 12 covalent compounds. H2 plus O2, that is how they exist as a result of them wanting, each of the atom wanting to get to a fully filled outer shell. And this is why you did those case studies, so that you know the formula of hydrogen and oxygen, them existing at room temperature, which is 25 degrees Celsius, is as H2 and also O2, and that will give you H2O, the very classic formula of water. 2 hydrogen atom and 1 oxygen atom chemically combined together. So this must be 2 hydrogen and this must be like that in order to balance the chemical equation. And this is G, this is a compound. Okay, and it's also another one of your case study, and this is a compound there, oxygen forming 2 covalent bond there. So G is a compound. H, this is the curve that resulted when cooling. So this is a cooling curve, and if you are not careful, you should really realize that what is happening here is this is starting to cool, start to change state, and this is ending for change of state. And if you see that when we change state for pure substance, they will have a fixed temperature for the change of state, where this will be horizontal line, but this is not a straight horizontal line, as you could see when you start to change state versus when you finish changing the state. You have a range of temperature, so you change your state over a range of temperature. So this must be impure substance, and when you are impure, you cannot be element or compound, it must be a mixture. Now solid I will not conduct electricity when it is a solid, will not conduct when it's a solid. Therefore this is not metal. We cannot say that it's ionic or something. We know it's not metal because metal conduct when it's solid. Second information, melts at a fixed temperature to become a conductor. Melts at a fixed temperature. So it is a pure substance. It cannot be a mixture. It cannot be an element because it's not metal. But it can conduct when molten. Can conduct when molten. Conduct electricity when molten, and it has a fixed melting point, so it's got to be a compound there. I must be a compound. How about J? All the atoms in a molecule. So remember that molecule consists of two or more atoms chemically combined together, and when the atoms are identical, then you get something called an element because it only contains one type of atoms. Elements can be molecule, element can be atoms, all right? Element can be molecules, element can be atoms, such as noble gases, all right? So J must be element there. So not the easiest, but not the hardest thing in the world, provided you read the information given and you know how to interpret information, and you know your lower secondary science, which is on atoms, elements, compounds, and mixtures. All right. Question 2, some elements have many isotopes. So we have 3 isotopes of element X. Definition of isotopes, this question is asking you, but it's asking you use the data from the table to show they are isotopes of the same element. So this is basically asking you to define, but you must use data from the table. You must use the data in order to get the final 1 mark. If you just define without using the data, you don't get the mark because you're not reading the question at all. And they're asking you for 1, 2, and 3. So here you can see they have the same number of protons. So all of 1, 2, and 3 have same number of protons, but that is not using the data. I have to use the data, so I will put a bracket 16 protons. Alright, so I've stated the definitions, but it's incomplete because now I need to look at the number of neutrons. Okay, but different number of neutrons, i.e. one has 13 neutrons. So it's stating the obvious really, but I'm using the data in the table to show that I know which one I am using. Okay, 3 has 15 neutrons, so all of them that have different neutrons, I am just showing very clearly. Use the data from the table, not just definition on its own. For that final 2 marks, you gotta show something about the data from the table, because that's what the question says if you read the question. All right, explain how the data suggests that they have the same chemical reactions. Chemical reactions is to do with your number of valence electrons. This is all stated in your lesson notes, and they have all part of your MCQs in the checkpoint for atomic structure, as well as in the work, in the exercises that you did for your atomic structure assignments, as well as atomic structure tests. Similar kind of question has come out in your MCQ. Then here they are asking you as part of structured questions. All right, so the number of electrons in the outer shell is to do with valence electrons. They have the same number of valence electrons. So all of the isotopes above, use the data in the table, right, have 6 valence electrons, or you can say 6 electrons in the outer shells based on what information they give you. But I know valence means the number of valence electrons refer to the electrons in the outer shell. Therefore, they have, I'm kind of repeating the question here really, but anyway, they have or they show same chemical reactivity because of same electronic configuration. Okay, so you could talk about same number of valence electrons, you could talk about same electronic configuration, which come from a result of having the same number of valence. Well, not really That's not really true. It's down to the number of valence electrons. I probably shouldn't say same electronic configuration. I'm gonna remove that. Okay. Now part C, element Y and element Z also have isotopes. So there are two different elements, yeah, that's why Y and Z there. So this is about isotope element Y and isotope element Z. As you could see, different number of protons, therefore different elements. Okay, identify element X, Y and Z. Well, you look at the proton number, which is atomic number, which you're given in periodic table for free. Okay, so open up your periodic table. I can tell you element X, which is 16 protons, is going to be sulfur. So 16 proton, so number of proton equal to 16. Element Y has 8 proton, there's going to be oxygen. And element 30, I will have to refer to periodic table. Element 30 is zinc. Okay, and these are obtained from the proton number, which is also known as atomic number and stated in the atomic structure syllabus and also in the notes, lesson notes, as part of the lesson objective, and also in the lesson note part itself, there is definition of proton number, and we keep on using atomic number, proton number, identity of the element. Now, sulfur, oxygen, and zinc, which one has the lowest melting point and which one has the highest melting point? So, sulfur exists as this S8 molecule, which I show you at some point 2 or 3 times before, and they are also available on the blog site as the PDF file, which you had referred to, I think, which you did your corrections on, I think. And this is O2 molecule, and then you have zinc metal. So among all of these, this is a simple molecular structure. This is a giant metallic structure. Highest melting point is going to be zinc, and zinc is, well, they want you element X, Y, and Z. So the element Z is going to be zinc. I don't put zinc in there. And the lowest will be the oxygen. And S8 will have higher melting point than oxygen. So oxygen is Y, and then there's X. Okay. In terms of the explanation, the giant versus the simple is the easy one. Okay. Zinc has giant metallic structure. Well, zinc, or you can say Z, I guess. Zinc or Z. Zinc has giant metallic structure, singular. While X, which is sulfur, and Y, which is oxygen, have simple molecular structure. So this is in the work solution section of the blog site, and it's been there. I have the record of it. It's been there since the school holiday about a month ago, which you use for your corrections, I think. Okay. And then what else? Therefore, for melting, what are we breaking? I already started the structure. So for melting, melting Z, I should say melting Z, which is giant metallic structure, requires a lot more energy to break the strong metallic bonds, between the cations and the sea of delocalized valence electrons. I don't want to run out of space there. And then requires a lot more energy to break that. Then weak intermolecular forces between simple covalent molecules, i.e. the X and Y. Okay, but then S8 versus O2, S8 has stronger intermolecular forces. In fact, I can say it has stronger van der Waals, and van der Waals come down to total number of electrons due to more total number of electrons in the molecule than O2. Okay, so S8 is actually X, so that is X, and O2 is actually Y. Okay, so these things between the S8 molecule, there's another S8 molecule, those are van der Waals. This thing, without counting, 2 oxygen. Oxygen is above sulfur in the periodic table. Oxygen has lesser electrons when you have 2 of them compared to when you have 8 of this element, which is below oxygen, which has more protons, therefore more electrons, and therefore stronger van der Waals, and therefore more energy is required to break the van der Waals, which is just a bit stronger than the one between O2, but not as strong as this strong metallic bond between the cations and the C of delocalized valence electrons, and they are part of the definition for metallic bond as the giant metallic structure. Question 3. So we have this classic diffusion experiment. So this is HCl, this is NH3, and this is ammonium. If you remember in the MCQ questions, there was that thing called ammonium chloride. Well, it was ammonium ion, NH4 plus and Cl minus. So it's a giant ionic structure. It's an ionic compound. This is simple molecular. This is also simple molecular. And this is actually a classic acid-base reaction, which you will do again and again very soon when you go on to do acid and bases topic. They want you to calculate molecular masses, similar like exercise you did earlier for one of the multiple choice question. So this is just 17, because 14 times 1 plus 3 times 1 is 17. Here you have 1 times 1 for hydrogen, and you have 1 chlorine, each of which is 35.5. From the periodic table atomic mass, the sum of the atomic mass give you relative molecular masses. Alright? Things you did a couple of months ago. I finished this bit. There is 1 mark for it, for both of these. Now the student makes this conclusion. The rate of diffusion is inversely proportional to the relative molecular mass of each gas. So it's saying that the diffusion rate is inversely proportional to the MR. This is the idea of inversely proportional. This is proportional. 1 over means inverse. 1 over means inverse. So when I write diffusion rate like that, and then 1 over that, it means diffusion rate is inversely proportional to MR. There are 2 bits to it. Do the measurements support this conclusion? Yes or no? Explain your reasoning. I think I'll explain first. Okay, I always like to explain first, because once you say yes or no, it seems like you're trying to make something fit which might not be correct, and that's why a lot of students always fall into that trap. You need to look at these and see whether it makes sense or not. The distance travel, NH3 travel further. NH3 travels 60 cm, HCl travel 40 cm. NH3 travel further, NH3 diffuses over a longer distance. For the fixed time, it travels longer, so it diffuses faster. Alright, so for the fixed time, or for a fixed time, NH3 travels 60 cm, a further distance, then 40 cm travel by HCl, and this is because NH3 is lighter. Use it as an evidence versus the heavier, or I should say then heavier HCl, bracket MR 36.5. Because you are heavier, because you are lighter, you travel a further distance, therefore NH3 diffuses faster. Therefore, NH3 diffuses faster as MR is smaller. So the smaller the MR, the faster you diffuse. So the smaller the MR, which is NH3, MR is 17 smaller, you diffuses faster because you travel a further distance than the heavier one. Therefore, what I can say is, yes, it supports. And therefore, yes, the conclusion is supported. So don't forget that there are 2 bits to the questions, and it's not just about yes or no. You really need to think about the reasoning based on the data. Okay, measurements, if you see here, measurements plural, and that means these are the data. You gotta use data to support your answer, not just factual. All right, it's all about being a scientist. Now the next bit of the question is to do with repeating at a lower temperature. So now you don't change anything, you still have NH3, you still have HCl, but you do it at a lower temperature. How does temperature affect rate of diffusion? Rate of diffusion. So it's not really directly stated in the syllabus, but there's another bit of the syllabus on how temperature affects how fast the particles can move. Temperature is defined as a measure of your average kinetic energy. It's not the first time I mention it ever since the first lesson in states of matter. Temperature is defined as the average measure of your kinetic energy. The lower the temperature, the lower is your average kinetic energy, so you don't move as fast. If you don't move as fast, you don't travel as fast, you don't diffuse as fast. All right. So what about the observations made in experiment A and B? So just because you don't diffuse as fast, you will still diffuse, you will still get a white ring, and because you are using the exact same thing, okay, NH3 and HCl, they will still meet at the same point because they still have the same molecular mass, so they will still meet at the same point, but it will just take them longer to reach this point because each of them will have lower kinetic energy due to lower temperature. So they want 2 things. They want similarity and they want differences. All right. So despite the lower temperature, the NH3 and HCl will still diffuse, still have the same molecular mass, still have same MR, therefore will meet or will form the white solid at the same position, at the exact same, do they call it position? So you get this white ring of solid, right? So that's why I say you form the white solid at the exact same position as experiment A. So that is your similarity. Experiment A was the one at higher temperature. Okay, now the difference. Okay, lower temperature means slower rate of diffusion, means particles have, they are not asking for explanation actually, but I have just explained it. Actually, it's not required because they just want the similarity and the difference. I just decided to explain it because it's easier. You never know, one day they're going to ask you to explain it. Yeah. So in this question, even if you don't explain it, you might still get the mark if you get the trend correctly. Sorry, not the trend, the similarity or the difference correctly. Okay, let me know if I mark you down, and I can award you the mark provided you get the similarity or the difference correctly. Okay, even without reason, because that has not been asked in this question, but I've just included the reason because you never know the next time you might need it, or the next time someone might ask you this. All right, so lower temperature means particles have lesser kinetic energy, therefore diffuse slower, travel slower, i.e. the ring, the white ring forms slower. It just takes longer time for the ring to form because each of these will diffuse a bit slower, but they will still meet at the exact same point there. So that's it for that. Nope, not the end of that question yet. So there's more diffusion here. So bromine is a liquid, as I told you earlier. Bromine is Br2 that exists as diatomic molecule, and between the bromine you have these weak intermolecular forces that you break when you melt or when you boil, but you also have covalent bond between the atoms that you do not break for melting or boiling. Okay, so for melting point, boiling point, this is what you break, not this one. Now, low boiling point because of the simple molecular structure. Now, after 30 seconds, you could smell the bromine in the other part of the room. They want you to use kinetic particle theory. This is very, very important. This is not biology. This is your chemistry definition of diffusion. So they haven't used the term diffusion here, but they say why you could be smelled on the other side of the room, because the bromine particle diffuse. Okay, so the bromine particles can diffuse, i.e. they move randomly. So definition of diffusion, they move randomly. There refers to bromine particles. If you decide just to write there without referring to bromine particle first of all, then it doesn't have a meaning. But I started by talking about bromine particles can diffuse, so they refer to bromine particles. If you don't use the right term, you might not get the marks. Okay, so the bromine particles move randomly in all directions from a region of high concentration, which is where the technicians spill it. Where the spillage happened, and then the technician can smell it because it goes from this region of high concentration of bromine to the region of low concentration, to another region, to a region of lower concentration, i.e. where the technician stands. Okay, so in doing so, actually there is actually part of my 2 points in there already. Move randomly in all directions. My second point is actually somewhere from a region of low concentration today. And my third point really got 3 marks, right? The bromine particles would have mixed with the air particles to a uniform concentration. As a result of it moving from a region of high concentration to a region of low concentrations, the bromine particle will spread itself out evenly throughout the whole volume of the room. Hence, you can smell the bromine at any part of the room. Okay, so therefore can smell in any part of the room. Therefore can smell in any part of the room. Okay. Question 4 is part of a case study on diamond and graphite. So these are your giant molecular structure stated very clearly in the syllabus. We have done these similar kind of questions for your classwork and homework for your assignment. I think it was work 2 or work 3, which, you know, the lecture tutorials, the tutorial video has been made online, like, I don't know, sometime last month or about a month and a half ago. And we've gone through the corrections. We've done similar questions for the topical test, which again we did the corrections on. So you have had some time to revise on your own, and if that doesn't help, then I don't know what else will help really. Okay, so you might need to figure out on your own what you expect from O-level chemistry without pumping in the right work, as well as a little bit of quality and asking questions when things don't make sense at all, and using all the resources available to you, including the textbook, the lesson notes, the lecture tutorials, the tutorial videos, the work solutions, and I don't know, etc., by asking questions. So graphite is a soft material which is used as a lubricant. Okay, so a lubricant and the soft material. So graphite has a layered structure. It's actually a layered 2-dimensional structures, but the layered structure is very, very important. With only weak van der Waals forces. Van der Waals, make sure you can spell properly. Van der Waals forces to be overcome or broken as the layers slide over each other easily, therefore soft lubricant. Kind of repeating the question, so I don't want to talk too much about it, but layer structure means you can slide over each other, and that's why you are only breaking the weak van der Waals forces and not just intermolecular forces. Make sure you know that we are breaking this, not the covalent bonds, because we are not talking about melting and boiling. We're talking about a property, another aspect of the properties of graphite. All right. The other bit is to do with diamond being very hard. That's why we use it as a drilling bit and for cutting through very hard substances for mining. Okay, we don't use them to cut normal stuff. We don't use them mainly for mining purposes, especially when we need to dig into the ground. Okay, so diamond has a rigid three-dimensional structure. Has a very rigid three-dimensional structure, so it is not a layered or two-dimensional structure. It is instead a rigid three-dimensional structures where many strong covalent bonds needs to be broken, where many strong covalent bond need to be broken upon applying force. Therefore very hard. It's to do with the structure as well as one need to be broken. The structure here is like this, and you're not breaking covalent bond, you're just sliding over the layers. Now the last bit is another classic case study, the good conductor, the graphite being used as electrodes in batteries, and diamond, you know, we don't use diamond to conduct electricity because they don't conduct electricity at all. In the structure of graphite, each carbon atom, as I showed earlier in one of the MCQ questions, you must be able to sketch the structure as well. Each carbon atoms only uses 3 out of 4 valence electrons for covalent bonding. Therefore, has 1 free electron, it's not ion, it's electrons on every carbon to conduct electricity. But for diamond, because they're asking 2 of them, there's 1 and 2, so always structure your sentence like this. For diamond, all valence electron on each carbon I use for bonding, I use for covalent bonding. If you know the structure of diamond, is all bonded to 4 other carbon. Therefore, no free electrons. No free electron at all on carbon. So no electrons left on each of the carbon in diamond, so you can't conduct electricity there. Phew, okay, question 5. So we have selenium and sulfur, group 6. So group number tells you the number of valence electrons. Electron distribution is the same as electron configuration, is to the same as electronic arrangement. So selenium is further down the periodic table. They say it's 2 plus 8 plus 18 plus 6. So this is the 4th shell. This is the 1st, 2nd, 3rd. This is the 4th shell. So if you look at your periodic table, this is period 4, group 6 for selenium. Selenium has the symbol Se. They want you to draw dot and cross. They want you to show this ionic compound, the charges on the ions, okay, and the arrangement of the valency electrons. So only valence electrons. Okay, so this is with potassium. Potassium is K, this is group 1, this is group 6. So this one will gain 2 electrons to get to a fully filled outer shell. This one will lose 1 electrons to get to a fully outer shell. So we'll have K plus and Se2 minus. And therefore we need 2 times K plus. so that the +1 and the +1 can cancel out the -2 charges. These are very important in your diagram because not just drawing K+, not just drawing these, you need to get the multiple correct because ionic compound is not charged at all. And you can use the crisscross method if you can't imagine it, or if you can't see lowest common multiple, which is a primary school mathematics. Okay, +1 times 2 is +2, -2 times 1 is -2. Overall, ionic compound has 0 charge. Compound is not ion. Ionic compound is not charged. Ionic compound has 0 charge. Ionic compound contain ions that are charged, and therefore the charges must be balanced. Either we do the crisscross or we do LCM between 1 and 2, which are the electron being lost, which are the electrons being gained, and therefore they will give you LCM being 2. So we need 2 electrons being lost, we need 2 of these, we need 2 electrons being gained, we need 1 of these. Draw the valence shell, so I know I need 2 of them. I don't know, I mean, I typically, never mind, I'll draw the shell. Okay, so K, so this is a potassium ion. Oops, sorry, hang on. They don't want that. You need to read the question carefully. Use the dot for potassium. Use dot for potassium. So dot, and it's not even like the dot that I normally draw. It's this specific circle thing. So after potassium loses electrons, loses the 1 outer shell electrons, you get a K+. Do not forget the charges, even if they don't tell you to. When it's an ion, it's a K+. You need 2 of it. So either you draw 2 of it, which I could draw 2 of it, like this, alright, or like this. I could draw 1 there and 1 there. Okay, and then I could draw Se, which is the selenium chemical symbol. I'll draw the outer shell. Oops, I don't want that. Draw the shell first, and then 1, 2, 3, 4, 5, 6. One of these electrons come from one of these having lost 1 electron from the atom, but it's still incomplete, so I need another one of these group 1 metal that lose another valence electrons to me. Altogether, I have gained 2 electrons from my atom that has got 6 valence electrons. Now I'm an ion. Okay, either this or you show specifically, you draw 2 times this and 1 of these, but you gotta follow the instruction, cross for the selenium, dot for the potassium, show the charges and show the correct multiplicity, the multiples, in order to get to a balanced charges in terms of ionic compound having no charge, for that 3 marks there. Okay. The next thing is to do with arrangement of valency electrons again, outer shell electrons, molecule. So we are talking about covalent bond because they talk about molecule. Selenium chloride. So when you have, I don't know, OH2 is like this, but hydrogen is group 1, they form single covalent bond. When you have OCl2 is like that, chlorine is in group 7, they form single covalent bond. Oxygen still form 2 covalent bond. When you have SeCl2, it will look like this. Okay, this is not dot and cross. I've just done my working on the side to relate to my most basic case study. But of course, hydrogen doesn't have any outer shell electrons. Chlorine has outer shell electrons, and I need to show this using the dot for the chlorine. Okay, so selenium. I don't want to draw a shell, it's a bit messy here. So selenium, I'm gonna use the cross as required. I would have 4 more electrons that are unused. Selenium is group 6. 6 valence electrons. I use 1 there, 2 there for bonding. I still have 4 more because 6 minus 2 is 4. So I'll have 4 more. And I have dot cross chlorine. Oops, sorry, cross like dot. The big dot for the chlorine. But do not make the mistake. Chlorine is not hydrogen. Hydrogen has 1 outer shell electrons. Chlorine has 7 outer shell electrons. So I will have 1, 2, 3, 4, 5, 6 because I used 1 for covalent bonding already. 1, 2, 3, 4, 5, 6. And believe it or not, there you go. Alright. predict two differences in physical properties. Okay, one of which is going to be electrical conductivity, straight from the syllabus. The other one is to do with melting point and boiling point, which is again straight from the syllabus. Alright, so in terms of formula, so this is SeCl2, this is K2S, because 2 of the K plus, 1 of the, Se2 minus, K2Se. So K2Se, ionic compounds. They are not asking us to explain, so I'll just state much higher melting point, melting and boiling point. Then SeCl2, which is simple covalent molecules. And the second one will be K2Se, conducts electricity but not in the solid state when molten, and or aqueous means dissolved in water, but SeCl2 does not conduct electricity in any states, not when you melt it, not when you boil it. They just do not conduct electricity because there's no free electrons or no free ions, whereas you got free ions from the ionic compounds when they become molten or when they become aqueous. Question 6 is to do with structure and bonding again, but here you have non-metallic elements, so we are looking at covalent bond. So ammonia, NH3, what is the one present in ammonia? So in ammonia, we are looking to label what is this, this, and this. Well, I hope you know it, okay? Somehow this question is easier than the previous question. Now they want you to draw ammonia. It's one of the 12 or 11 examples from your case studies. So, I really hope you know how to draw it. They haven't mentioned valence electrons. They haven't mentioned it. No mention of only valence electrons or valence shells. You see, they don't mention anywhere in these questions. They just say in a molecule of ammonia. So I need to be very, very careful. I need to draw the inner shell as well. So if I draw the nitrogen inner shell first, because I'm showing two different shells, so I need to oh, I hate that thing there. Why do they keep on doing that to me? Okay, never mind. 1, 2, and then 1, 2, and then hydrogen, cross dot, hydrogen, cross dot. Nope, I can do better than that. Hydrogen, and then don't forget the nitrogen has got well, it's in group 5. It has got 5 valence electrons. I have used 1, 2, 3 out of 5 valence electrons for bonding. I still have 2 there, so it's a 2.5. This one is just 1. Okay, so nice and happy there. But what is important is it hasn't asked you to only show valence shells, so I need to be sensible because they haven't asked me to do that. Now I have calcium chloride. Calcium is the first 20 element. You know the first 20 element. Calcium is group 2, period 4. So it's going to have calcium 2 plus because of the group 2, 2 valence electrons. It wants to lose the 2 outer shell electrons to get to a fully filled outer shell. Chloride, Cl minus, because chlorine is group 7. So it wants to gain 1 electrons to get to a fully filled outer shell. So I hope you know how to do the formulas already. So you can do the crisscross method, where the 1 goes to the calcium 2 plus, and the 2, you only take the numerical value. This is the exact same method as the lowest common multiple, because you want to balance out the charges. So you have plus 2 multiplied by 1 is plus 2. Minus 1 multiplied by 2 is minus 2. When you add plus 2 and minus 2 together, ionic compound. Compound is not ion. Compound is not charge. That is the objective of trying to balance out the charges with the correct multiples of the ions based on the charges is to get to overall zero charge. Now the type of bonding is definitely ionic bond. Again, they haven't asked you to just show the valence shell, so you need to be careful and draw each and every one. So I have calcium 2 plus, I need to have one calcium 2 plus, I need to show 2 Cl minus, or at least very clearly show that there are 2 of the Cl minus. I'll start by drawing the calcium first. 1, 2, 3. I don't know why it keep on doing this. I don't want it to be fill. No fill. Okay, cool. I think I get the idea now why it keep on doing that. 1, 2, 3. So calcium atom, 20 electrons, 2.8.2. From the periodic table, you should know how to play the snake ladder game. They are part of your lesson from about 2 months or 3 months ago. And then these 18 electrons, calcium 2 plus ion, 2.8.8. And that's why I'm drawing 3 shell only. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Don't forget the charges. Just because they don't tell you to, you gotta have charges because you have already lost electrons from the atoms. Now the Cl minus. If I use cross for calcium, I need to use dot for the chlorine. 2 in the first shell. 8 in the second shell. And then I will have 7 originally. 7 of these dots because chlorine atom has 7 valence electron, but I will get chloride ion. That's because it gained 1 electron from the calcium. That's why only one chlorine atom can only gain 1 electrons, but the calcium atom is losing 2 electrons. I need another one of these to get the other electrons. All right. So this is going to be the Cl minus. Make sure you draw the charges despite them not telling you to. No charges mean not ions, and you know this is ionic bond. It's funny how people think you get ionic bond without ions. All right. So at the moment the charges are not balanced. So either you draw another one of these, okay, such as nope, I don't want that. Either you draw another one of these like this to show that one of these balance out 2 of these, where one of these will have 1 of these cross from calcium and another of these cross will go here. It loses 2 electrons, 1 goes to each of the one of the 2 chlorine atom. Each of these are ions. Or if you don't want to draw them again, you gotta show specifically that the anion must be multiplied by 2. Okay, such as if I cancel this out, then I will say times 2 times 1. So that means 1 of these with 2 of these. Okay, but just for simplicity's sake, let me say I just draw both of them so that it's clear for you. But if you want to take the shortcut, you need to be very clear you have 1 of these and 2 of these, just how you would get the formula in the first place. All right. Now calcium is in group 2, chlorine is in group 7. Explains in terms of the number of outer shell electrons, that means valence electrons, and the electron transfer. So 1 of these, 2 of these. How calcium and chlorine atoms form ions, and then give the formula of the ions form for that 3 marks. Okay. In terms of number of valence electrons and electron transfer, calcium has 2 valence electrons because it's in group 2, therefore loses 2 electrons to form calcium 2 plus ions that have 2.8.8 electronic configuration with fully filled third shell. IE of argon. Okay, now how about the chlorine? Chlorine has 7 valence electrons, group 7, not group 8, group 7. Therefore gains 1 electrons to form Cl- ions that have 2.8.8 electronic configuration. So you do not need to write exactly the same way as I've written, but you gotta have all the information with fully filled third shell again. Maybe I can say with fully filled outer shell, valence shell maybe, because I like to use the term valence. So I can say fully filled valence shell. All right. Overall, we need 1 calcium 2 plus and 2 Cl- ions to get overall charge of 0 for CaCl2 ionic compound. I think there's something that I'm missing. I haven't talked about the electron transfer yet, so I need to really include that. Okay, so the 2 electron loss, 1 goes to each of the chlorine atoms. Each chlorine atom gains 1 electrons from the 2 electron loss from calcium. That's why the calcium 2 plus the calcium atom give away 2 electrons, but each Cl-, each Cl atom can only gain 1. That's why you need 2 Cl atom to get 2 electrons altogether. That's why we get this ratio of 1 calcium 2 plus and 2 Cl-. Finally, so we have, well, actually there's no really information in figure 6, but we know the ideal kinetic particle theory. We know the solid and the molten ionic compounds have different electrical conductivity. So there are 2 bits to it, solid and molten. So in the solid state, you know the particles, the calcium 2 plus and the Cl- ions are held in fixed positions where they can only vibrate about the fixed positions, therefore not free to move, therefore cannot conduct electricity, therefore cannot conduct electricity. But then when molten refers to melting. Okay, that means solid goes to liquid. The liquid ions, so meaning calcium 2 plus and Cl-, they are now liquid, are able to slide past each other. That is to do with states of matter as part of the distinguishing properties of solid, liquid and gas given in the syllabus for states of matter topic number 1. Slide past each other, therefore free to move. They've got a bit more spacing compared to the solid particles. They are held tightly. I forgot this term, tightly in a fixed position. So free to move in the liquid state, free to move, therefore can conduct. That's it for that question. In this next question, so we're being asked to define relative atomic mass. I hope you know that when you have an element, so when you have, I don't know, element X, and then you have A and B, in this kind of international format notation, notation, it's not the same as your periodic table, because at the bottom is what you define as proton or atomic number, and on top you define that as mass or nucleon number. So they are your fixed case study. In your periodic table, these are not mass and nucleon number. In your periodic table, you have atomic number, which is the same as proton number, and then you have relative atomic mass, and that's the biggest danger of all. Relative atomic mass is not always equal to mass or nucleon number. These are exact whole number. These are not exact whole number because of the definition that is being involved here. Relative atomic mass is defined in the syllabus as the average mass. It is the average mass. So it's got to do with average, and it's the average mass of all the isotopes present of an element. So different, so one particular element can have different isotopes. So do with the average mass of the isotopes of an element. That is the first part of the definition. Sometimes it's 1 mark, sometimes it's a 2 mark definition, but usually you always have to compare it. Okay, so you say compared to, or you can use the term relative to 1 over 12 the mass of n atom. If you don't like n atom, you can use 1 atom of carbon 12. This is the international standard. The reference standard is relative to 1/12 times the mass of an atom of carbon 12. 1/12 times the mass of an atom of carbon 12. It's got to be 1 atom because you're comparing the mass of the individual atoms of the isotopes of the element. Such as for chlorine, in fact, that is actually what they're being asked here. So chlorine 35 and chlorine 37, these are what you call mass or nucleon number. These are whole number, but then there are only 2 isotopes of chlorine. They are present in the ratio of 3:1 or 75% is to 25%. This is a case study, and of course you know how to work them out to get you the relative atomic mass 35.5, because we did that as one whole lesson. It's actually part of the lecture tutorial, which is the lesson video that have been made online since 2 months ago when we did atomic structure, which of course you had gone back and looked through if you didn't cover this on your own based on the syllabus when you are revising. These are also part of your assignment from before, and we have gone through the corrections and stuff, which of course you had gone through on your own as well. If you hadn't understood, you would have asked because you had gone through it on your own. So chlorine has 2 isotopes. So chlorine 35 is to chlorine 37 are present in a 3:1 ratio, or you can say isotopic abundances, relative abundances, or you can say percentage abundances of chlorine 35 to chlorine 37 is 75%, 25%. Therefore, the relative atomic mass of chlorine is going to be 35 times 3. There are 3 of these chlorine 35 is to 1 times 37, or you can do 37 times 1. It's the exact same thing, divided by, because we want the average masses, we do not divide by the average masses, we divide by the other one, which is 3 plus 1, and this is down to your mathematics. Okay, you have done this calculation before. I have shown you this calculation before, and if you hadn't gone back to revisit it, so there is no one you can blame. All right, literally no one. The next bit is the last bit of this whole exam paper. Uranium is a metal. Describe the structure and bonding. So a bit stingy, well, not really stingy for the 2 marks. You could have shown it with a diagram. With anything, diagram always speak a better story than writing a lot, because once you draw a diagram and label it, you know exactly what is happening, because this is the delocalized valence electrons, and then these are cations, and the attractions between the cations and the delocalized valence electron is what you call metallic bonding. So uranium has a giant metallic structure. You want to describe it in word with strong metallic bonds, but then there is not full description because you have not identified between what and what. That is the key thing. Okay, between the cations, the metal cations, and the C of delocalized valence electrons. Why is it when you draw the diagram you have to label it? The same thing is when you are asked to describe it in words, you also have to be able to use these individual words to describe the whole structure and the bonding between them for metal. Okay, so uranium is a metal, giant metallic structure, strong metallic bonds between these two particular lattice particles. Okay, so that's it for this exam paper. It's not the hardest, it's not the easiest, because there are bits and pieces. They are there to trick students as usual. And if you are easily tricked, then you can't really blame anyone. We have done everything from the syllabus, and we've gone through it everything from the syllabus again and again. And that's what revision is. If you have just been reading, it hasn't worked out, then, well, you know, it's just the way it is. Okay, so don't forget, if you need something else from me, you can ask me questions when you see me in school. I'm always available if I'm not on holiday, and you have known it from the very beginning. Okay, if you're watching this video as an outsider, you can send questions or comment on the video, and don't forget to subscribe and share the channel widely with all your friends, your chat group, study group, and other people as well. Okay, see you in the next tutorial video.